Hey everybody, welcome to week 2 of distance learning. Last week you worked on some distance time graphs and did some Desmos activities, and I appreciate everybody that submitted something. There are a few of you that haven't yet, so you can make sure you get on that just to review before you start today's lesson. Today we're going to go a little bit further and look at slope as a rate of change. Okay, so follow along, make sure you're taking a note as we go, and pause the video and feel free to email me if you have any questions. Here we go. So here's question 1. Sarah on the soccer team runs every morning before school. One day she ran 5 kilometers in 20 minutes. This seems an awful lot like a distance time question. I'm going to start with question B, actually. Let's graph that. So if I just quickly sketch a little graph, running 5 kilometers in 20 minutes, we're going to put time on my x-axis, distance on my y-axis. 5 kilometers in 20 minutes, let's do 5, 10, 15, 20. And distance 1, 2, 3, 4, 5. She starts at a distance of 0 and a time of 0. In 20 minutes, she's gone 5 kilometers. Let's put a point at 20 and 5. Connect that with a nice straight line. You can even extend it if she keeps running at the same speed. We can figure out how much further she's gone. But that's the answer to question B. Question A, calculate the rate of change of Sarah's distance from her starting point. Well, we know that slope and rate of change are the same. M is the variable we use to represent slope. And so her distance and her time could be represented like this point, 20 and 5. Last week we did slope formula y2 minus y1 over x2 minus x1. Remember, this is the origin down here. That's 0, 0. So we can consider this the point x2 and y2. We consider the origin as the point x1 and y1. I'm just going to sub in the pieces that I know. So I know that y2 is 5. I know y1 is 0. I know x2 is 20. I know x1 is 0. I'm going to sub that in. I get 5 minus 0 over 20 minus 0, which gives me a slope of 5 over 20. Work that out in your calculator. 5 divided by 20 is a number 0.25. Part C says, explain the meaning of that. What does that mean? And how can it relate to the graph? Well, 0.25 has units attached to it. That's kilometers per minute. My y-axis was in kilometers. My x-axis was in minutes. So Sarah ran at a rate of 0.25 kilometers per minute. That's the slope of this line. If I used any 2 points on this line and found the rise and the run, no matter what 2 points I picked, I would always see that my slope worked out to 0.25. Okay, example 2. I've got a graph here that represents how far a car has driven and the amount of fuel left in its fuel tank. And so I know when I start driving, I have 65 liters of fuel in my tank. And by the time I'm kind of done my trip, I've got 5 liters of gas in my fuel tank and I've driven 500 kilometers. I want to calculate the slope of this graph. So again, slope is y2 minus y1 over x2 minus x1. So I do say that it's a little bit easier if I make the point furthest on my right x2 and y2, and if I make the point furthest on my left x1 and y1, things just work out a little bit easier. So I've got 5 minus 65 divided by 500 minus 0, or negative 60 over 500. Again, work that out on your calculator. My slope ends up being negative 60 divided by 500, or negative 0.12. So question B says interpret the slope as a rate of change. What does that mean? What does a slope of negative 0.12 mean in this context? Well, we have to remember this has units attached to it. I am using the units of liters per kilometer. So as far as interpreting, when I drive 500 kilometers and I lose 60 liters of gas, I lose about 0.12 liters for every kilometer I drive. It's negative because I'm losing gasoline. I'm going down. Notice again, if you read this graph from left to right, you can see the graph is going down, which means it should have a negative slope. Just to summarize, when we're talking about slope, we're talking about rate of change as well. Slope and rate of change are two words that can be used almost interchangeably. When we're talking about rate of change, we need to include units. So the other day when we were doing distance time graphs, we were mostly working with kilometers per hour. Today we did things like liters per kilometer or kilometers per minute. We always need to include units when we're talking about a rate of change. If we're just graphing two pieces of information like this picture here, we don't necessarily need to use units. If we're just graphing pure numbers, the units don't matter. What matters is that we can calculate the rise and the run between these 2 points. So again, that special formula we've been using is y2 minus y1 over x2 minus x1. And if I use my little trick and I make the point furthest on the right-hand side y2 and x2, I can create this equation 5 minus 2 divided by 6 minus 1. Simplifying, I get 3 over 5. And again, because there's no units attached, this would be just a slope of 3 over 5. I know I'm going up 3 for every 5 units I move to the right. Okay, so up 3, that's the rise, and then right 5 units, that's the run. Again, that formula that you need to start burning into your brains to find the slope of a line segment, we subtract the y values, and we subtract the x values, and that gives us the rise and the run. So thanks for watching. That's this week's video lesson. I'm working on getting some office hours put together, and I'll post those in the math classroom as soon as I've settled on my specific time. Of course, you can always email me if you have any questions, or post those questions in Google Classroom. You're probably not the only one that have them. And otherwise, I hope you're all doing well, staying safe, and I'm looking forward to when we can all be together again. Have a good one.